Welcome to the in-service video for the Dylan Navigator Surgical Gamma Detection System. In this video, we will cover the steps on how to operate the Navigator 2.0 control unit as well as the different Navigator probes. There are 4 quick topics that we will cover on this video, and they are the Dylan Navigator 2.0 control unit, the Navigator wireless probe, the Navigator cabled probe, clinical procedures, and specialty probes. The Navigator 2.0 control unit is rechargeable, cordless, and compact. It can attach to an IV pole or the Navigator rolling cart. First, you will need a fully charged lithium-ion control battery. Remember to always start a procedure with a fully charged battery. The battery mitigates the need of a power cord, which can add an unnecessary trip hazard in the operating room. A fully charged battery will provide over 10 hours of continuous use. To charge the battery, insert the battery into the charging cradle, which, as you can see, has 2 ports. The system comes with 2 batteries. This way, you can charge 2 batteries simultaneously and keep them plugged and charged and ready to go when needed. There is an indicator light on the charger to let you know the status of the charge. Flashing green means charging. Solid green means fully charged and ready to unplug. You can quickly check the battery charge level on the actual battery by pressing this button. 4 lines show the battery is fully charged. To insert the battery to the control unit, open the battery box door and insert the battery face up. Close the latch securely, ensuring that it is fully latched. The control unit has an anti-glare display with high LED visibility, which makes it easy to see from anywhere in the room. As previously mentioned, for additional mobility, the control unit can be attached to the Navigator roll stand. First, attach the pole clamp to the control unit by inserting the top ears into the back of the control unit and gently screw down the clamp to the system. Now the control unit is ready to be mounted on the roll cart. Open the knob and place the control unit to the desired height. Tighten it down into position. Now you're ready to connect the probe you desire. The control unit is compatible with all Navigator wireless or cabled probes. If you choose to store away the Navigator system or safely transport it to another location, you can use the custom-designed Navigator 2.0 storage and carrying case. The Dylan Navigator 2.0 can be used for radio-guided procedures involving technetium-99 and iodine-125 for tumor localization. On the back of the unit, you will find 4 source options indicating which source the system is being used to locate. Prior to the procedure, ensure that you've selected the correct source. There is an indicator light on the bottom of the display to confirm that the control unit is set to the appropriate source for the procedure. The system should be set to scan for use during the procedure. Let's talk about the range button here on the front of the control unit. The range button adjusts the audible pitch to customize the sound profile for the amount of activity present. 1 times is for low event rates, all events are heard. 10 times are for medium event rates, 1 in 10 events are heard. 100 times for high event rates, 1 in 100 events are heard. Pressing the range button cycles through the different ranges. Select the one that's most useful to the procedure being performed. You may start with 1 times, but if navigation is difficult due to higher counts, you may want to switch to 10 times. The threshold button is for use with only a cabled probe. It controls the count range of gamma energy detected by the probe. When the threshold button is off, the indicator is not illuminated, and all gamma energy, including scattered gamma rays, are detected. When the threshold is on, the indicator is illuminated. In this setting, the detection of scattered gamma rays is reduced or eliminated. The count button here indicates a 10-second count. When the count button has been pressed and let go, the count indicator on the display screen is illuminated, and the display screen will show the increasing counts. The probe must be held in a fixed position for the entire duration of the 10-second count. When the 10 seconds are complete, the control unit beeps, and the total count is shown in the display. You will see that there is a battery indicator light to indicate the battery life for the control unit. When the light indicates that the battery is at a 25% charge, the battery should be immediately replaced and recharged. Lastly, you will see the test indicator light here, which is used only when performing a test check and not during a procedure. In order to comply with standards of various accrediting organizations, such as the Joint Commission and the CDC, critical devices such as surgical gamma probes are sterilized at central processing. The wireless probe will typically come to the operating room in a sterilization tray, such as this. First, turn on the control unit by pressing the on button. You remove the sterile probe in the sterile field, give it a light shake so that it links to the control unit. The settings on the control unit are preset, so you're ready to go instantly. Unlike some other surgical gamma probe systems, there is no long wait time for calibration, extended pairing time for our wireless probes, or booting up. However, you can always check to make sure the settings were not changed during the previous procedure. The scan knob is set to scan. If not, there will be a blinking light which indicates that the system is in test mode and can't be used to operate. The threshold light is on and the range is on 1x, and you are set to the desired radiation source. When turned on, the display will read 0. The probe utilizes a convenient off-the-shelf Duracell CR2 battery, which are easy to source and easy to change. A new battery is replaced by central processing after cleaning and prior to each sterilization. We will show the steps. Open the cap of the probe and remove the battery holder. Take a new battery and insert inside the battery holder with the plus next to this antenna. Insert the battery holder with the battery inside the probe with the antenna facing up and gently hand rotate until the holder opening is aligned with the serial number. After this, rotate the cap in place until this O-ring completely disappears. There may be a blinking light, which is normal. Do not hold the probe by the neck because you may run the risk of twisting the shaft. A quick test can be performed to make sure the wireless probe is in optimal working condition. You can use a test check source to hear the sound and read counts. The wireless probe has a self-calibrating mechanism, so all you need is to make sure the probe is reading counts. The exact number of the counts does not matter because it is dependent on the activity of the radiation source at hand. In order to comply with standards of various accrediting organizations, such as Joint Commission and the CDC, critical devices such as surgical gamma probes are sterilized at central processing. The wired probe will typically come to the operating room in a sterilization tray. You remove the sterile probe and cable into the sterile field. Prior connecting the probe to the control unit, make sure the control unit is off. First, connect the probe to the cable by making sure the red dots are aligned. Connect the cable to the control unit by making sure you align both arrows. Then press the Instant Power On button on the control unit. When turned on, the display will read 0. These settings on the control unit are preset, so you're ready to go instantly. Once the system is powered on, it is ready for use. Unlike some other surgical gamma probe systems, there is no long wait time for calibration, extended pairing time, or booting up. However, you can always check to make sure the settings were not changed during the previous procedure. Make sure the scan switch is set to scan. If the switch is not on scan mode, there will be a blinking light in front of the unit which indicates that the system is in test mode and can't be used for operation. Make sure the threshold light is on, the range is on 1x, and you are set to the desired radiation source. For example, technetium-99 is for sentinel lymph node procedures. Every 6 months, you can perform this quick test by following these simple steps. This test will help to make sure the probe is in optimal working condition. You can use a test check source to hear the sound and read the counts. While holding the probe steady on a check source, perform the following measurements. Set the switch to the positive setting. The calibration light will blink, indicating that you are in testing mode. Press the 10-second count and record the number. Now set to the 0 setting, and repeat by pressing the 10-second count and record the number. Now set to the negative setting, and repeat by pressing the 10-second count and record the number. The counts on the 0 setting should be higher than at the negative and positive settings. The exact number of the counts does not matter because it is dependent on the activity of the radiation source at hand. After you are done, make sure to turn the knob to the scan mode. The calibration light is turned off. Now you're ready to use the system. The Dillon Navigator 2.0 surgical gamma system can be paired with a variety of different probes for various radio-guided surgical procedures. The Navigator probes utilize advanced probe technology, which has been optimized to facilitate precise localization in a broad range of anatomy. The specialized probes remove the need for background filtering. Here are the probes that Dillon offers. The 14mm angled and straight probe. These probes are made in both wireless and cabled versions. Both wireless and wired probes outperform competitive probes. The internal collimator and detector design gives excellent performance in multiple applications. Most common among them is during lymph node mapping, sentinel biopsy procedures, and tumor localization. 11mm head and neck probe. Precise localization of parathyroid adenomas requires a probe designed with the unique requirements in the specific anatomy. The 11mm head and neck probe is designed uniquely for this purpose. We recommend that you visit this site for a detailed course on this procedure. The Daniel Vatz probe or Daniel lung probe. This probe addresses the challenges of localizing small, difficult to visualize lesions in MIS pulmonary procedures. It also eliminates guesswork on tissue margins and target location. We recommend that you visit this site for a detailed course on this procedure. The 10mm laparoscopic probe, available in a long and short length. These probes are commonly used in radio-guided, minimally invasive surgical procedures for thoracic and abdominal malignancies. Here is a long laparoscopic probe. Thank you for taking the time to learn about our Navigator 2.0 surgical gamma detection system. For additional information or technical assistance, please contact your local Dillon representative.